talking about allowable shear stress. Design for masonry shear walls. So I was chair of the 2016 Code Committee. Two of my biggest accomplishments perhaps of my career were that we actually produced a code that had fewer pages than the previous edition. So that's, I don't know if we're the only structural code to ever have fewer pages than the previous edition, but certainly it's rare. No, we did not decrease the font size, but I thought about that. The second thing is that myself and a few others convinced the Masonry Society to go to a 6-year cycle. So the next code will be coming out 2022, Masonry code, so we have gone to 6-year cycle. I know codes were changing rapidly and just trying to help practicing engineers who have a hard time, I know, just keeping up with all the changes. We will be having a public comment period on the 2022 code that starts about the 1st of June and goes through about the middle of July. So there'll be more information on the Masonry Society website where you can get a draft copy of the code in the month of June, first part of July, and submit any sort of public comment that you have on that. So we will get started. I guess I should also say happy April Fool's Day. I guess it's, I assume it was not a coincidence that S.K. Goshen Associates asked me to speak on April Fool's Day. So here's what we're going to do today. We're going to talk about different shear wall types, masonry shear wall types, a little bit about allowable stress design. We'll look at design of a shear wall with a single layer of reinforcement. So this would be like perhaps a pier between some windows, or just a short length of masonry wall that would just have a single layer of reinforcement. We'll learn some things, I think, in terms of behavior that are useful. We'll then take a break and look at the design of shear walls with multiple layers of reinforcement, so a longer shear wall. We'll also spend some time on special reinforced shear walls, some of the requirements of that. And then after the break, we'll look at several things. We'll look at design of flange shear walls. We'll also look at shear friction provisions, which were added in 2016. So just as an introduction then, a little bit about shear wall types and allowable stress design. So there's actually 5 types of shear walls that are masonry shear walls that are defined. There's actually a few more. There's some pre-stressed shear walls. There's some AAC shear walls. But we'll just focus really on actually 3 of these. There are 2 unreinforced shear walls, the ordinary plane and detailed plane. Those are not being covered here in this webinar, that they're not used a lot. The design of those is actually pretty easy. It's P over A plus MC over I. Actually, I should say minus P over A, so the axial force, the compressive force, actually helps us. And that's almost what always controls either out of plane or in plane with unreinforced masonry, generally just the overturning there. But we're going to be looking at reinforced masonry, and there's the 3 types: the ordinary reinforced, the intermediate reinforced, and the special reinforced. So if you're in seismic design category D or higher, you do have to use the special reinforced shear wall. In lower design seismic categories, seismic design categories, you can use the ordinary or intermediate reinforced shear wall. So here's some of the requirements sort of laid out, the sort of detailing requirements. Perhaps it's easiest just to sort of look at a picture. So here's for the ordinary walls. So it's a reinforcement. The blue lines are reinforcement of at least 0.2 squared. So a number 4 bar or larger. So horizontally, we needed above and below openings extending at least 40 bar diameters or 24 inches. This reinforcement is not in addition to structural reinforcement. So suppose we needed a number 5 bar here just to carry the load of the masonry above it, any sort of dead load, perhaps some live load or some load coming in from a roof or something. So if we had a number 5 bar in the lintel, that means that we don't have to add in extra reinforcement. And then we also have to have joint reinforcement at 16 inches or bond beams at 10 feet. And then horizontal reinforcement at all diaphragms and within 16 inches of the top of the wall. Vertical reinforcement then has to be at the corners and ends of wall within 8 inches of that. on either sides of openings. They have to be within 16 inches of the opening. The reason for that is that some people put control joints here sort of at the top of the lintel there. So what we have is that we can move the bar over sort of one cell and get beyond that control joint there. We have to be within 8 inches of control joints and a maximum spacing of 10 feet. For intermediate reinforced walls, that reduces down to 4 feet for that. And that's the only difference. For special reinforced walls, the maximum space in the vertical reinforcement is 1/3 the length of the wall, 1/3 the height of the wall, or a maximum of 48 inches for running bond or 24 inches not laid in running bond.